Okay, we're going to go over this question I gave you guys earlier today to think about. This is really the length of the angle bisector. Remember what we mean by bisecting? What this means is we're bisecting angle C here. Okay, and angle C by bisecting is we're cutting this angle into two equal pieces. And that's what it means to bisect angle C. Now, we have this line here called the angle bisector. And that line has a length called S. So this is a proof of the length of the angle bisector formula where S is going to be 2AB cosine X over the sum of A and B. And there's various ways to prove this. What the book recommends, I think, is it's not very clear. It says consider law of sines. Now, law of sines is very helpful to get a relationship for the angle bisector, but I think it's easier to prove this fact. Yes, consider law of sines, but consider the area question in, I should say, that law of sine worksheet. So what I'm going to do is I'm going to get rid of all of this other stuff that we had earlier today, and we don't really need these facts. It's going to be a lot easier going about it this way. So if we go to that section for law of sines, remember you had a formula, and here's what we're going to use. So if we have this angle called theta here, and this is length AB, remember we proved that the area is 1/2 AB sine of the angle theta. And this gives us area here. And this is what we're going to use. Okay, we're going to use this relationship here. And this is the key. So when I say to you, we're going to find the area of triangle here now. We're going to look at this triangle here in gray. Really triangle ABC. And I'm going to use a different color. So I'm going to find the angle, or I should say, we're going to find this area of this triangle here, right? So what I know is the area, that big area here, is 1/2 AB sine of angle C. So we're using this angle C here. And yes, we know angle C is going to be 2x. So this is really 1/2 AB sine of 2x. And this is for the area of triangle ABC. All right, so that's no different than what I just wrote down up here. Okay, so we know this area. And I'm going to go back and I'm going to say to you, we're going to look at two other triangles here. So that big area, and we're going to look at this triangle here. And we're going to use the area formula there too. So this is going to be, if we let this be side here, or let that point be, I don't know, D. Okay, we're going to use the area formula now. So this area formula is going to be in orange. Maybe we'll do orange writing, right? It'll be 1/2 AS. Okay, those are the sides, and then the angle is going to be X. So in orange, we say A is 1/2 AX sine X. And this is the area of triangle. Oh, what do we call that? BDC here. It's the orange triangle, BDC. So BDC now. Okay. And similarly, we're going to say that in green, we can find the area there of triangle DCA, and that in green is going to be 1/2 S, B, and then sine X. So in green, our area is 1/2 BX sine X. And that's area of triangle. We're calling that now ACD. Okay. All right. And then the blue triangle, I'm going to remind you guys, we got the blue triangle here. The big triangle in blue. You can see that there. I'm going to put it on the outside maybe. Okay, let's undo that and we'll put it on the outside. And so here's what I'm talking about. The area of the blue area is equal to the sum, okay, of the two smaller triangles. So I can say big A, this is going to be A1, and this area maybe is A2, and then the big area is A. So here's what I mean, right? A, the big area, is equal to the orange area, A1 plus that green area, A2. So if we write down what A is, you say, what is A? This is A, ladies and gentlemen. It's 1/2 AB sine 2x. So we're going to say here, let's put this in blue, 1/2 AB sine 2x is going to equal 1/2 AX sine x. And I can keep it in blue. 1/2 AX sine x. Now we have to add A2, so A1, A2, we have to add this area now. 1/2 BX sine x. So we're going to say now 1/2 BX sine x. Okay, now we're pretty much done. Let me double check. And I think I have something. It's S, it's not X. Yeah, this portion right here, sorry. So in green, yeah, this is S. Oops. Yeah, sorry. A little typo. This is S, and then this was also S. Okay. Apologize. Because S is a side here, right? You see the side is right here. This is my S. So we're looking at these two sides with this angle and these two sides with this angle here. All right, now we're good. We just have to change our letters to S. Now we're fine. Okay, so we could do our algebra now. All right, 1/2 cancels if I divide both sides by 1/2. And now you're left with AB sine 2x equal to AS sine x plus BS sine x. I'm going to solve for S. I'm going to actually factor, right? I'm going to bring out the S, and I have A sine x plus B sine x. Actually, I'm going to factor out we're going to factor this out. We're going to factor out the common factor. Okay, here's what's common on the right side. What's common is, let's get the right highlighter. S sine x, S sine x. So we're going to get S sine x. And we're left with the sum AB. And on the right side, I have AB sine of 2x. So what I'm going to do, ladies and gentlemen, I'm going to solve for S. Let's write that in red. Okay, we're going to solve for S now, the letter S. And you'd solve for S by dividing both sides here by, it looks like, sine A plus B. And so on the right side, we have the cancellation. So we're left with this on the left. We get AB sine 2x over, and this is going to be sine of x. All right. Okay. So let's see what we have. sine of x, and that's s. You know, I like having s on the left. So now I have AB sine 2x over sine x. All right, we're almost done. You see, what you're going to use here now is the identity. This is sine double angle. There's a double angle identity. Sine double angle 2x is 2 sine x cosine x. So, you know, here's an example of how, and if we write everything down, you know, identities really exist to make our lives easier. Because now it can cancel my sine x. And now, and I think there's going to be an a plus b somewhere. We forgot. Yeah. There's an a plus b down here. And we end up with really 2ab cosine x over a plus b. So let's double check. Is that what we had to prove? Yes, it is. So this is the proof of what we call here, ladies and gentlemen. It's the length of the angle bisector. Okay, so that's where this comes from. It's the length of the angle bisector. And I think the hint about finding area in the law of sine section really is a better hint than they gave us this afternoon in the book, right? This afternoon they said, hey, use law of sines. And it's like, well, no, you know, use the area formula from law of sines. I think this now makes this angle bisector formula a lot easier to do. And it's based on finding areas here, ladies and gentlemen. You know, area here, this big area. And that was covered in the law of sines. So it's not Huron's formula, you know, it's right in here, but very useful. So this is why the formulas are useful and the identities are useful, because it gives us something very significant, because now I can find the length of that angle bisector, and that's one way to prove this. So I wanted to share with you guys this you know, formula, since we took it out of the book. It looked pretty nice to do, and hope you guys enjoy this proof and derivation. I'm going to upload it and send you notification in Canvas. Thank you.